Today we're going to talk about quadratic functions. Most of this you should remember from Algebra 2, but there are a few little things that you may not, so be careful, be attentive, and take good notes where you need to. The first thing, let's just define what a quadratic function is. A quadratic function is a second-degree polynomial function in one variable that can be written in the form f of x or y equals ax squared plus bx plus c, where a is any number other than 0 and b and c are any numbers at all. That's the definition of a quadratic function. And typically, we write them in that order. We write the quadratic term first, then the linear term, then the constant term, so that we can kind of see them and we can keep them straight in our heads. The graph of quadratic functions is called a parabola. It's a cup-shaped curve that opens either upward or downward. If the coefficient of the quadratic term is positive something x squared, it will open upward. If it is negative something x squared, it will open downward. And it will continue to spread out forever and ever in whichever direction it's heading. Every parabola is symmetric about the line that runs through the middle, the vertical line that runs through the middle. You can fold it in half along there. It's called the axis of symmetry. So here for this example, you can see that the axis of symmetry is x equals positive 1. But here, it's x equals negative 2. So we could fold it along those lines. That's the axis of symmetry. See this point right here, negative 2, 5, and this one, positive 1, negative 4. Do y'all know what that point's called?
Vertex.
That's the vertex, yeah. And so we're going to spend a lot of time today talking about how to find the vertex, because that's the really important number. That's the number that the function turns around at. So here, if I follow this function, I'm decreasing, 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 but when I get here, I turn around and start increasing. That also acts as the minimum point for an upward parabola or a maximum point for a downward parabola, and that's very useful in a lot of business and physics applications. Here's the chart that sort of summarizes everything we talked about on the previous slide. Take a minute, read through it, and make sure you understand everything that's listed here. Basically, it's just reminding you that you can tell just by looking at the leading coefficient whether it opens up or down, that the vertex is the turning point. However, we haven't talked about how to find the vertex yet. That's going to come a little later. The minimum or maximum point will always occur at the vertex for a parabola, and the axis of symmetry is the vertical line that goes through the parabola at the vertex. So for example, if the vertex is 1, negative 4, the axis of symmetry is the vertical line x equals positive 1. So you can just kind of glance through that. If you need to make any notes about it, go ahead and do so. And if not, we'll move on. That brings us to standard form of a quadratic function. Standard form isn't what you think it is. It's more like the standard form of a circle. Standard form is when you have the equation already grouped up into a certain way, where there's a set of parentheses right here squared, there's a coefficient usually in front of that parenthesis, and there's a constant on the end. What standard form does is it lets you easily identify the vertex. So if an equation is in standard form, you can see the vertex very easily. The vertex will be h, k, where h is the number that makes the parenthesis 0, and k is the number added to the end over here. So that's standard form. It's not the most useful of forms because usually we don't have it in standard form, and it's a lot of work to get it in standard form. The same way it is to take a general form of a circle and put it in standard form, it's a lot of work. The great thing about parabolas, though, is that if it's not in standard form, you don't have to convert it to standard form to find the vertex. There are other ways to find the vertex of a parabola. There aren't other ways to find the center of a circle besides converting it to standard form. So these are actually a little bit easier. Using what we've just learned about standard form, we want to find the vertex of the graph of each of these quadratic functions. So if you look at these two examples that were given, notice that they're already in standard form. Let's look at both of them kind of individually. For part A, we have f of x equals 2 times the parenthesis x minus 3 quantity squared plus 5. That's called standard form. When you have a parenthesis squared, maybe a constant in front, and maybe a constant added to the end. That is standard form of a quadratic function, and you can look at it and tell its vertex. For part A, what's the vertex there?
3, 5.
Positive 3, comma, positive 5. Notice again that the x value of the vertex is what makes the parenthesis 0, just like the center of a circle. It's the opposite of what you think it should be. You look at that and you see a negative 3, but the important number is positive 3. And then the y value of the vertex is just this constant here on the end. This number in front, the 2, doesn't have anything to do with the vertex. That number just tells you whether it opens up or down. It opens upward because there's a positive 2 there. So there's the answer to the question. That vertex is 3, comma 5. That brings us to part B. F of x equals negative 3 times the quantity x plus 2 squared minus 4. That equation is also in standard form. Does that second equation open upward or downward? Downward, because the coefficient in front of the parenthesis is negative 3. What's the vertex of this?
-2, -4.
Let's see, it is negative 2, negative 4. It's what makes the parenthesis 0, comma, this number right here. So it's pretty easy if you already have standard form to find the vertex. Any questions about that? Let's move on. If we want to graph a quadratic function, the most important thing to do is to find the vertex and then determine whether that function opens upward or downward. Once you do that, you just need to get some additional points around the vertex to tell you what your parabola looks like. Now, technically, all you really would have to do there is make a table of values after you find the vertex. But we're going to ask, for the sake of later on, and especially those of you heading to calculus and business calculus and all of those things in college, we're going to ask that you also take the time to find the x and y intercepts while you're graphing, because that's going to be really important. So maybe on a quiz or test, or even a homework problem, I may not ask you to graph the whole thing, but I would ask you to find the intercepts and the vertex. So you need to be able to do all of that. So we're going to find the vertex, determine whether it's up or down, find the x-intercepts and the y-intercepts, and then we're going to need at least one more point on the graph. So I need you total to have how many points? 3 to 5, depending on whether it has x-intercepts or not. Okay? Then you simply draw a smooth curve through the points found in steps 2 through 5. Take a minute and make note of that if you need to. Let's take this example and let's graph it. Let's find the vertex and the intercepts as one additional point. Because it's already in standard form, we should be able to run through this fairly easily. So, first part, what's the vertex?
-1, -8.
Vertex is -1, -8. Does it open upward or downward?
Upward.
Upward, because there's a positive 2 here in front. All right, so that's what we know about it so far. Next, we would like to find the intercepts. The quickest one to find is the y-intercept, so let's do that first. To find the y-intercept, you simply substitute 0 in the place of x. So we have y equals, or f of x equals, it doesn't matter, 2 times 0 plus 1 squared minus 8, which equals -6. Okay, so we know that our y-intercept is the point 0, comma, -6. So far I have 2 points on this parabola and I know it opens upward. Next we're going to look for the x-intercept. Now, a quadratic function can have up to 2 x-intercepts, but it doesn't have to have any, because it may not cross the x-axis. If it's all above or all below the x-axis, you may not get any. If that happens, you'll see them as imaginary and you'll know they're just not really on the graph. So let's go now and let's find the x-intercepts, if they have any. To find x-intercepts, what do I do? Let y be 0. So we have 0 equals 2 parentheses x plus 1 quantity squared minus 8.
Minus 2.
So I'm going to move the 8 and divide by 2 to isolate the parenthesis. I'm trying to get to that x, right? So I'm going to move the 8, divide by 2. And that gives me x plus 1 quantity squared equals positive 4. Then how do I get rid of that square?
Square root.
Square root it. You can use the square root property, yeah. Just don't forget that when you do this, you have to put positive or negative 2. So our x-intercepts appear to be negative 1 plus or minus 2. And in this case, move this up a little bit here so we have a little more room. In this case, that gives us which two numbers? Positive 1 and negative 3. So that's where it's going to hit the x-axis, at positive 1 comma 0 and negative 3 comma 0. So that gives us 4 points. And truthfully, that's probably enough. If you want to go ahead and graph it. So let's start graphing it and then we'll talk about whether we need to go and find another point. I'm going to put my first dot at negative 1, negative 8. There's my vertex. Next, I'm going to put the y-intercept on at 0, negative 6. Then I'm going to put the x-intercepts on at 1, 0, and negative 3, 0. So that kind of looks uneven. So why don't we go ahead and find another point? How about the point where x is negative 2? Let's see what should go there. Does anybody want to guess what should go there? This is my vertex. Okay? I know it also has to come around this way through here. If I want to find an additional point, what number should be here if I plug in negative 2? What y value? Does anyone know?
Negative 6.
Negative 6. Why? What's going to force that point right there to be there?
It's
Because it has to be symmetric about that vertex there. So we know that if this is 0, negative 6, and it's 1 away from the vertex this way, then 1 away this way must also have the same y value. But you could find that if you weren't sure by simply taking that value, negative 2, plugging it into the original, and you would see that you would get negative 6 to find that additional point.
you just like make sure like
Just to make sure, yeah. You could go up and just plug in negative 2 here. Negative 2 plus 1 is negative 1, squared is positive 1. 2 times positive 1 is 2, and 2 minus 8 is negative 6. So you could check that. So you could always find as many additional points as you want. And that's a quick introduction to how to graph a parabola.